Hello everyone, my topic is about Kubernetes YARN and the combination of Kubernetes and YARN. And first let me introduce myself. Actually, I'm from Alibaba Sigma teams in charge of the online dispatch systems, and now I'm in doing the big data companies, and we're trying to develop YARN in our companies. And I used to work in Hadoop community for several years, in charge of the community maintenance. So today I'm going to talk about the yarns about the what and why of co-location and why Alibaba want to do this. And then I want to talk about the architecture based on Kubernetes. And then, based on my past experience, I would like to talk about the Kubernetes and YARN, these hybrid architectures, online, offline, dispatch, advantage and disadvantages. Lastly, I will summarize these two different platforms. First of all, why we choose co-location. In Alibaba, actually, we've done some service, and according to the statistics, the data center utilization of Alibaba before co-location is very low. The CPU utilization was only 10% before we adopt co-location. And that is a very low utilization rate. We've wasted a lot of capacities. According to Gartner, they have talked about the 80% rule of Gartner, which means that 80%就是说，你这个 IT 的预算80%呢，实际上都被浪费了。也就是说 ，so 80% of the IT budget gets simply spent on keeping the lights on, which means that 80% of our capacity we're using to make our software and platform run smoothly. So just like the high expressway here, you can see in the picture on the left-hand side, on the one directions you can see there's a traffic jam. On the other side actually there's not so much traffic, so which means that we need to fully leverage the capacities. Our workloads in the Alibaba data centers split into two different topics. First, we have online service, including the following agenda. First, the online service in charge of the commercial platforms, which is the web applications that we use daily in Taobao, Tmall, retail apps, Hema, and other search capacities. And also the online servers are in charge of take on the payment platform, for example, Alipay. And then in the online service, you also have the middleware, the queue servers, the cache servers, and other database. So in Alibaba, we believe that we have already 100% financed, which means that all the things we're using pod, container technologies on the Sigma pod management. And also, there are a lot of other workloads, which is offline dispatch, for example, jobs. When it comes to jobs, you have big data batch jobs, for example, MR, and ODPS, which is Alibaba own project, own tools. And you have Flink is about real-time calculation, real-time computing. So before we do co-location, we have some legacy issues. For example, the Sigma, this is our team. We're in charge of the online platforms. Also have Fuxi. Fuxi is in charge of the offline jobs. Sigma in charge of Tmall, Taobao, search and middleware, which is online jobs, and Fuxi in charge of offline, which is ODPS, MR, Sparks, and jobs. So Sigma is the same Kubernetes with Super Kubernetes, and Fuxi is the same with YARN. YARN is also in charge of the offline jobs. So this is a compare and contrast about online service and offline jobs. So I have several different features. As you can see on the slides, online service. When it comes to online shopping, web apps, and the payment service, the advantage is very sensitive to latency. For example, if you want to buy something, you need to finish the end-to-end transaction within several hundred milliseconds. However, when it comes to offline batch jobs, it is very insensitive to latencies. For some offline jobs, it takes 1 or 2 hours to finish the transactions. It is very also costly, and also the online service is very high priority for us. So if there's some accidents, we need to give priority to the online jobs. So it is in the forefront of dealing with customers. However, when it comes to batch jobs offline, it is very low priority because we don't contact the clients in the batch jobs. And also the traffic pattern difference between online and offline. When it comes to online service, the traffic pattern is that it peaks at daytime and very lean at nighttime because all of our customers are sleeping. When it comes to batch jobs, the daytime is lean. It peaked at nighttime. There are some applications or other offline jobs, so we're doing it at night. And lastly, when it comes to fault tolerance, these two are quite different. When it comes to online service, we need high availability, high resilience. When there's a failures, it is zero tolerance. For example, if you're a client, you are buying online, you don't want the system to fail. However, when it comes to offline batch jobs, if the task failed, then we need to do a retry. It is acceptable. It has a very high fault tolerance. We need to do retry, and it is acceptable when there's a fail and retry. So because of on and offline have these different mutual complementary relations, so then if we can fully leverage these features, if we can run it on the same platform based on the same infrastructure, then we can fully leverage all the resources without any waste. So over the past 2 or 3 years, within Alibaba, our Sigma team trying to have a co-location clusters, come up with these co-location clusters to have this hardware that can be adapted to Sigma and Fuxi, and we can do the same maintenance based on the same infrastructure. In the past, Borg also published a paper talking about co-location. It said it is a production and non-production jobs combined together. If we combine production and non-production jobs together, then we need to invest 20 or 30 more machines. So because production task is the same with our online service, there's a spike. And they need to reserve all the resource for those spike. But most of the time, the resource was wasted, was not fully leveraged. So non-production jobs can actually use those additional resource to run their jobs. In this way, we can fully leverage the improve the utilization rate. So what is co-location? A co-location is a hybrid development that supports both online service and offline jobs using the same hardware. Using this technology, we can improve the cluster's utilization rate, lower the cost, lower the hardware investment. So when it comes to co-location, we have actually make some comparisons in terms of CPU utilization. Before co-location, the CPU utilization rate was only around 40%. After the co-location was adopted, we improved to 40%. So in the past, it was only 10%. So we improved by 30%. So within Alibaba, this is a huge improvement. This is a qualitative improvement with co-location. And also, we've done some statistics, the RT impact on online service. The RT impact can be maintained within 5%. We have internal isolation technology to support us with that, to make sure that the influence is as low as possible. Previously, I was talking about the Alibaba status quo. So co-location technologies in Alibaba was fairly mature compared to the. We have actually withstood the test of different rounds of Double 11 events. So during Double 11, our co-location technologies withstood thousands of transactions and data So if we can actually make it open source and feed it back to the community, or make it provide it to other same scale operators who care about CPU utilization, then it will be very useful. So we have two important projects. First is Kubernetes, second is YARN. And YARN is a sub-program for Kubernetes, and using HDFS using the storage, and YARN is for dispatch and calculating, computing, and Flink is also doing the computing. All of this was run on YARN platforms. With the statistics, they could do the computing.
Kubernetes and YARN's the co-location architecture. For Kubernetes, I won't go into details. Most of you must understand. You have a kubectl and send the command to the master to develop the related points. And for YARN, the structure is similar. The master in the middle is like the control plane of Kubernetes. And this is the kubelet of Kubernetes. And it has a application master, this concept, like the controller of Kubernetes, like the application master and its own components. For application master, it will ask resources from the resource master, and when it returns, it will launch the related container on the related nodes to finish a scheduling. Unlike Kubernetes, all of them are running in different containers, but this one is run as a whole, including the scheduling management and dispatching. All of them are in professional units. And for this picture, if you see some technical script of Alibaba, you may see there are something similar but something different. But it is an internal product, Alibaba, because for Kubernetes and YARN, for this open source, it is the vision are different. So what I'm talking about may be different from what you have seen. So from the left is a Kubernetes, standard Kubernetes, and on the right is standard YARN, the cluster, and in the middle is cluster master and agent, and also the consoles that we developed targeting the hybrid. So at the beginning, for the whole cluster, during the initiation via console, we deliver a command to colocation master and to agent. For each cluster and machine, we will have a ratio like 40% to Kubernetes and 60% to YARN, this kind of a ratio. And after it is completed, each of the cluster will develop, and according to, and some of the files will follow the traditional pipeline, and some will move to the new. And of course, after they are all developed, the colocation master will dynamically make some API call, like the API server, expose some information, and they record all the save of the cluster to monitor all the information. If it discover the API resource is not enough, it will, based on the information reported by agent, to choose some nodes which are suitable to preempt the pass. The reason why we are doing this is we need to ensure the online demand is met. on our priority list for the online requests. And for the recess node, the API is to adjust the size of the node. And the YARN will automatically have a priority list to choose automatically to the task that will be run first and report to sales manager. And the whole process will be based on the prioritized list. In addition, the agent also involves C group parameters to make sure that for both ends the usage won't exceed the original C group size. So for every node, YARN also implemented a container concept like best efforts of Kubernetes. On every machine for Kubernetes, it's a half and half ratio. But in fact, there are still resources left. For YARN, it can also be used the resources you request but actually not used. Sometimes there will be a oversubscription to be distributed to other tasks. Because by definition, it's an opportunity the user is expecting. When Kubernetes grows, it will be adjusted automatically to delete some of the jobs. So this picture actually describes the C group, the hierarchy structure. On the first line is the exclusive core, which means some of the online services, because they have a high priority, will reserve some core. Like the 0 to 3 is reserved for some high priority core application, and 10 to 15 is for shared. And offline job is also have a high priority to use other share, and they achieve this kind of adjustment. And at the bottom are the jobs with the lowest priority, those parameters. So here, there's something different, is that at the bottom, this line and the first line are also sharing. We also cooperated with the internal team of Alibaba to develop some functions so that they could recognize whether the offline and online, when they are running, we can first guarantee the online tasks. But traditionally, it's hard to tell because you cannot tell whether it's online or offline. So for the pathways, it is of great importance. So we've described the general picture of dispatching and scheduling. But manually, we also have some time stress scheduling. Because for online service, the daytime the usage is high, but nighttime is relatively low. And during this period of time, we will make good use of those resources to conduct those offline tasks. So when online tasks in daytime are back, we will dynamically scale back to make the utilization more balanced. For Alibaba, we also have this unique scenario, is that the promotion day and normal day For example, like the Double 11 in the past, we have the separated cluster. We need to buy lots of machines to meet the demands of the data and traffic during the promotion day. But after that, they will very likely not be used anymore, which is a waste of resources. But now, during this hybrid, we can achieve a auto-scaling. All those green are online services, and the green and the orange are offline jobs. So before the promotion, we will manually adjust this green parts to adjust. That is how we did actually during the Double 11, which just passed. It is also related to the Infinite in terms of dispatching and scheduling. And for this application, some of them may need Infinite to be mounted on the same machine. And after the rush hour is passed during the promotion day, we will dynamically test the value. If it's if it's below the parameter, then we will also adjust the tasks gradually, which is also related to dispatching and scheduling, because when you are making the adjustments, you must make sure that the existing services must meet the demands. But rather than that, you cannot leave all the services to a single machine. And after that, we will rearrange the offline job. So during this process, it's 1 hour online and half hour offline, and that is our goal. So at last, I would like to talk about, because personally I have a deep development experience in the two projects, so I would like to tell the differences from their design and principle. First is Kubernetes. First is in charge of the dispatching. I think it is more related to operation and maintenance. We offer a final stage, and the system helps to adjust the current state to the final state. But for YARN, it's designed for the best job, the batch job. It has a first-class application concept. So for Kubernetes, it has an application, but in nature it is related to container. For YARN, for resource management, it will manage the whole application, and also a process involving restarts. We also have a hierarchy queue model. For Kubernetes, it's only a quota management. For YARN, it's an organization divided into 50%, and the sub-organization can receive 10% from the other 50%. So for YARN, it does not have the concept of container. So since you have the pod, you can have different combination to achieve different functions for targeting services. For Kubernetes, I think the KPI is targeting pods. Like we have this pod is a single execution, but for YARN, it's designed for batch. For example, my request, I would like 20 or many containers rather than a single one. And the creation and the deletion and the actions are batch actions. So it will be more suitable for the batch dispatching and scheduling. And also the scheduling units are quite different for Kubernetes. I think it's a more up. For container, it's the smallest primitive, such as application deployments are built around it.
This is a pod concept. So when it comes to YARN, it's actually centering applications. When we are doing the dispatch, it choose queue, and then choose the most prioritized queue. And also, it has a queue have capacities, so it's very complex, the logic. So you would choose the best queue, and then after the queue was chosen, and then he will use the user, and then after the six, this is describing the scheduling sequence of YARN. First queue, then user, and then application. So there's priority for applications. Kubernetes don't have application priority, but YARN have application priorities. So after they choose applications, and then choose a container request, or similar to pod. So for pod, it has also priorities. So it's like a top-down scheduling sequence. The reason is that when we're doing the dispatch, it's not like we have a lot of containers. So the mindset when they are developing YARN is that they want to have a center management. So in the communication, Kubernetes is quite different with YARN. Kubernetes is based on API server watch mechanisms. All of this was everything was stored in the etcd. The etcd is like the brain of Kubernetes. But for YARN, when it comes to communication, YARN is based on RPC. It's only application level metadata persisted. So the benefit of this is that when there's doing the recovery, you don't have to put all the things into a persistent data storage. This will lower the latency, and after the recovered, actually is from a memory state into a peers, and then you can get information from peers and then reconstruct the schedule. So however, Kubernetes put all of that in the etcd. It is also very easy. You can get information you want from etcd. So this is the difference between Kubernetes and YARN. With YARN, it's a big collection, so collectible performance is not so good compared with Kubernetes. And next is the container runtime. Kubernetes container runtime is CRI compatible, and it is using Docker technologies. However, YARN have Docker and tarball. So probably you're not familiar with tarball, but when you're doing or calling up jobs, it is not containerized, which means that on each node you need to put a code, artifact, and computation files need to localize into a local node. So for YARN, it is using a resource localization logic. So it is very complex, and it is related to different customers' access to. If the customers write private control, they want private control to their own resource, and each user can only access to your own resource. So that is their requirements. However, when it comes to Kubernetes using Docker, so all of these was uploaded to Docker, and this is not private. So previously I've talked about the Kubernetes and Docker difference. I want to do a summary of our session here. So because co-location in Alibaba is fairly mature, but it was not fully used in all the capacity of the Alibaba, and the Fuxi and the Sigma team, historically speaking, were developed by two different teams. So if we want to do co-location in Alibaba Group, it still takes a lot of time. There's still a long way to go. So we need to continue to invest in this, and also there's stability issues if you want to do the co-location, especially in our cores. And also new GPU and FPGA, new resource dimension dispatch, and some of the online jobs using CPU, but some jobs also use GPU to do the confirmation. And we hope that we could make the systems more intelligent, more automated, lower the manual labors. In the past, there's a lot of manual labors involved in our systems. So of course, our co-location technologies is a contribution by Fuxi and the Sigma team. So we hope that we can really make it open file, open source, to make all the big manufacturers, just like Alibaba, can adopt this technologies, lower their resource waste. And that is the end of my presentation. Thank you. 这个演讲能力我也是醉了，我去。中英夹杂，我疯了。I'm sorry, the audience is not using the microphone. The interpreter cannot hear the question. Okay, so the question is about whether we use YARN over Kubernetes. Well, actually, it is. Let's think it this way: YARN and Kubernetes, they're changing the dispatch method, using YARN to complement Kubernetes, but YARN didn't solve the resource allocation issues. If you're using YARN over Kubernetes, I believe co-location can achieve that, can help you to auto-dispatch your resource. So YARN over Kubernetes can help you to dispatch. And in the industry, YARN been in the industry for many years. A lot of companies have a whole set of DevOps systems based on YARN. So if we really want to force to use YARN over Kubernetes, it takes expertise to finish the job. But I believe that these two are not contradicted with each other. And YARN over Kubernetes does not cover all the jobs. It can only change my dispatch or deploy model. This cannot change or improve the resource utilization rate. We're now using the microphone. The interpreter cannot hear, so I'm sorry. Alright, so the question is about offline and online. Will it impact the networks? Yes, I think that our teams have already have online offline control package. So internally speaking, in the Alibaba groups, we actually have standards for on and offline, and there's a marks for the on and offline. So we put it to the portal, and they will recognize the marks. They know the traffics, and they will auto-tuning the online and offline traffic. Alright, so I'm not totally get your question. What you're talking about is about whether this will change YARN codes or Kubernetes codes. The audience is not using microphone. I cannot hear it, or sorry. So the question is about the Kubernetes request model and YARN request model. On a physical level, are they the same? So when it comes to Kubernetes resource model, request model, it have two different classifications. And when it comes to YARN, according to my knowledge, when I was actually involved in these programs, previously there's a picture giving you the CPU utilization, right? So apart from fixed CPU, the other CPU was shared, capacity was shared by Kubernetes and YARN. So when it comes to code changing, well, previously, if we change the node size, and then we can help the yarn to identify what kind of task need preemption, what kind of task don't need. So if we need a additional capacity, it is very hard because the externals, third parties don't know anything about the yarns and the Kubernetes. So we are trying to change the size of the node to identify the task, and then we could finish the task. I don't know whether I answered the question. Maybe we can talk about it after this conference. So when it comes to Flink within Alibaba groups, when it comes to Flink, we are running it on Yarn, and the other one is running on Fuxi platform. So now we don't do a co-location on these two. They are running on different clusters. So sorry, your question does not apply to this context. All right, so time's up, and thank you very much.